Okay, hi guys. Welcome to homework number 19. I'll be sharing the problems right away for homework 19. And here we go. So I have the first problem. It's saying right here, focus on concept question 04. A proton is released from rest at point A in a constant electric field and accelerates to point B. So an electron is released from rest at point B and accelerates to point A. So how does the change in the proton's electric potential energy compare with the change in the electron's electric potential energy? Okay. So we're going to see that they are actually the same because a proton moving in one direction is equal to an electron moving in opposite direction if they cover the same distance, okay? If they move in the same distance because of the charge E, negative E going that way. So if for this point, this guy is going to the right and it's positive, an electron is negative going to the left, so it's going in negative direction. So the negative and the negative will cancel and also be positive. So they'll have the same electric potential energy. Okay, so that's why the correct answer here is A. The change in the proton's electric potential energy is the same as the change in the electron's electric potential energy. Okay, now the next question, focus on concept question 08, says, the drawing shows a point charge Q equals positive charge 2 microcoulomb and two locations A and B. What is the electric potential difference VB minus VA? So just get V due to B is KQ over B, V due to A is KQ over A, where A is the distance from the point A to the Q and B is the distance from point B to Q. So when I do that, K is my constant, 9 times 10 to the 9 times the charge, the same charge Q 1.2, don't forget to convert to SI unit times 10 to the power negative 6, all over 2, I get that. A is 2, distance from Q to A. Then B, to get the potential at B, is distance from Q to B, which is 1. I do the same thing, the same charge, and I get this double of that. I take the difference. That's my potential, the difference. Is that okay? Okay. So that's how I get the potential difference there in volts. That's focus on concept question 08. Let's see chapter 19, problem 01. So during a particular thunderstorm, the electric potential between a cloud and the ground is V cloud minus V ground, which is given. So we have the potential difference given, and we say this is charged times potential difference is equal to our electric potential energy. So what is the change in electron's electric potential energy? So that will be charge times the potential difference we're given. So we know the charge of an electron, negative 1.6 times 10 to the power minus 19 times the potential difference we're given right here. 2.9 times 10 to the 8, and that gives you your answer here, negative. Okay. Okay. The next question, chapter 19, problem 02 says a particle with a charge of negative 1.7 microcoulomb and a mass of 2.5 times 10 to the power minus 6 kilogram is released from rest at a point A and accelerates towards B, arriving there with a speed d. So if I have the total energy at point A being electric and kinetic, since we're given all the speed and the charge, okay? So it has electric and kinetic energy here. And at B, electric and kinetic, we see at A starting from rest, so VA goes to 0. So if I take all the electric to one side and all the kinetic to the other side, I get this other equation. Okay, so it's starting from rest and it's a negatively charged particle moving to B. So B will be higher potential because a negative particle always go from lower to higher potential. So our potential difference is going to be B minus that of A, electric potential at B minus electric potential at A. But we know that electric potential is given by Q times potential difference. So that becomes electric potential at B minus electric potential at A divided by Q naught to be our potential difference. So when we do that, we simplify this guy with EPE B minus EPE A, noting that VA is 0. Then I have minus half mVB squared over Q naught is my potential difference. So half mVB squared over Q naught. So I just do that here with a negative sign, and then I solve, but I know Q is also negative, so the two negatives will cancel, and then I have a positive potential difference right there. So you expect potential at B to be higher at A, so the difference will be positive, for sure. Okay. Now the next problem is problem chapter 19, problem 6, go. In a television picture tube, electrons track the screen after being accelerated from rest through a potential difference of 33,000 volts. So we have our potential difference. So we are asked to find electron speed just before the electron strikes the screen. So the same problem, VA goes to 0. Our potential difference is here, it's given to us already. Then we find VB when VA is 0. So VB is the potential, electric potential energy difference here, times 2 divided by M. And then we'll have to take the square root of that. And then it's A minus B. If I change it to B minus A, I'll have to put a minus outside here. Then B minus A is actually the potential difference we are given in the problem, which is 33,000 volts because it's positive. So, and then the two negatives cancel. And then when I work these out, I will just get 10.8 times 10 to the 7 meters per second. So just be careful here when you change here to minus, because we want B minus A to be the potential difference, since the negative charge goes from lower to higher potential. Okay. The 2-point charges, that and that, are separated by 2.5 meters. What is the electric potential midway between them? So we get electric potential due to the first one, KQ1 over R, plus just scalar summation, just summation by algebraic addition. So KQ2 over R. But these R's are different, but because it's midway between the two charges, so the R is the same. R is actually half of 2.5. So I'm looking at half of 2.5 as my R, and I'll just sum KQ1 and KQ2. So it's just K over R out, Q1 plus Q2. So I do minus that plus that, and I get this. I multiply it, so this should give me negative because minus 8 is smaller than 2.3. So I'm going to get a negative answer. So that's just how you solve this one right here. You get the potential difference in volts, or the electric potential midway between them. Then right here, problem chapter 19, problem 22 says charges of minus Q and 2Q are fixed in the plane with a distance of 2 meters between them. A dashed line is drawn through the negative charge, as you can see here. So we are asked to find on the dashed line a distance L where the total potential is 0. So there are actually 2 points, one going up, another the same L distance going down. We'll still find the potential 0, but we want to get the positive one. So we're going to get the potential due to negative Q is K negative Q over the distance L. The potential due to 2, the distance between 2Q plus 2Q and here is L squared plus 2 squared square root. We want this whole distance. So it's this squared using Pythagoras plus 2 squared square root. So that will be K times plus 2Q divided by that distance squared. Square root. And then we want that to be 0. So what will L be if we want that V total, this sum, to be 0? So you just solve this, that 1 over L, you cancel, you divide by Q and K. So you have 1 over L equals plus 2 over L squared plus 2, that. And then L squared plus 2M squared equals 4L squared when you square both sides. Then the result becomes 1 over L squared equals 4 over L squared plus 2M squared. And then solving for L, we obtain this, or L equals 2M over square root of 3. So you're going to get 1.15. So this square root of 3 will give you a plus or a minus answer, but we are taking the plus answer in this case. Okay. Yeah, and that is the end of the homework 19. I'll see you guys next week. Thank you.